So there's a couple things I'm going to show you guys. I'm curious. I'll ask you if you've ever seen it a certain way. That first one, we did one sort of like that yesterday. That first one, where I give you letters and I tell you what the letters are. The thing you got to be careful about when you plug stuff in. So I tell you, A is -3. So technically, if you write this, you're wrong. Because this is -9. What I've written so far is -9. It's not what this says to do. This says square A. Here I'm squaring a part of it. Because what's 3 squared? 9. And then you put a negative on it. See? But what am I supposed to square? A. There you go. So if you wrote 9 there, you're right. But if you didn't write the parentheses, you're sort of wrong. Okay, maybe. This is why if you put in your calculator -3 squared and you get -9 and you ask the teacher, my calculator's freaking out, I know you squared something that's supposed to come out positive, it's because the calculator knows order operations. Exponents before multiply, right? 3 squared 9 times negative is -9. I like it. Okay, maybe. Okay, and then y was, where'd you go? 5, z was -2, and it was -3. Okay, so the slightly better way to do this is to follow order operations. You only have to break, and again, we talked about it. It's not breaking order operations to do distribution or something. It's just reorganizing the problem. But the only time you have to do that is when you cannot follow order operations. If this was x plus -3, what's x plus -3? I don't frickin' know. Then I would distribute because I can't do the inside first. But what is -2 plus -3? -5. I like it. And what's -3 squared? We already said is 9. Now would I put a 4 here? No. Hell no. Because what am I going to do very last thing? Subtraction, because that's the ass and the PEMDAS, right? So what I'm going to do next is this multiplication. What's -5 times -5?
25.
Positive 25. 34. I like it. So if you got -16, you weren't careful about the two negatives killing each other, right? You guys see that? Is that cool? Again, it's okay to make mistakes, especially when it's 0 stakes, like I'm not grading this thing. You want to kind of get the mistakes out of your system, but make sure you understand why they were wrong, why they're mistakes. All right. Number 2. So this is a little baby order operations problem. The biggest mistake is people put a 6 up there. I do not see 2 times 3 anywhere up there, and you guys are like, I could point it out to you, Jeff. This 2 is underneath. It's divided by 2. This 3's on top, right? You do it as it comes. What's the last thing I'm going to do up here? Add. Because this other thing is add. It's funny, Jeff. What? Right? So here I got 3 plus. That's just going to come for the ride. 3 plus. I don't know yet. What's the first thing I do? Yeah. Parentheses. And then what's the next thing I do? Exponents. 2 squared. 4. And now this is all MD. Multiplication division. You do it as it comes. So what's 4 divided by 2? 2. And what's 2 times 3?
6.
3 plus 6? 9. It's again, math is a foreign language. So this is related to like the grammar of math. Some languages put adjectives after. So in English we say, I live down in the blue house. In another language you would say, I live down in the house blue. Right? Because in another language, like what's important is house. What's secondarily important is what the hell it looks like. Do you guys kind of with me? I'm sure some of you guys know languages that work that way. There's all kinds of other ways that languages put things together to communicate the same idea. We just have to know this language. How do I look at things? And it doesn't match with our normal order because it's a different language. Okay. Let me leave you there. Sure. Oh yeah, 2B was one of our favorites. Let's see. I'm going to do this. What is kind of like the first thing I want to do on a simplification problem like this? Distribute. I like it. So you can free that. This stuff here, it's stuck. It can't go with anything else because it's stuck inside. So the first thing I do is free them up. Bring the -2 in. Are you going to work? Let's see. -2 times x? Crazy. -2 times -5y? Plus. That's an easy mistake to make. And now, believe it or not, this has everything to do with how fractions add and subtract. When I add and subtract, I have to have like terms. So what can I add 5x to? Or what can I put 5x with? Yeah, so 5x minus 2x, 3x. Right? Ground shaking. -3y plus 10y plus another 10y, 17y. Cool, become a y. Is that all right? All right, so that shouldn't be too new, the idea of like terms. Oh, it's total. There's a property called commutativity, which says, like, if I said 5 plus 8 plus 7, it's the same thing as 8 plus 5 plus 7. I can add whatever order I want to. So you can move stuff around. Okay. What's this next dude? Oh, yeah. Then we get like 4 fraction problems in a row. You're like, what the shit, Waller? But fractions, almost independent of the level of math, people have trouble with fractions. It's just because you don't really work with them as often as whole numbers. So there's kind of something cool with this. I pointed it out to somebody. It works all the time. Not every time it's perfect as you want it to, but you could do this in several steps. If you didn't immediately see what can go in, you could say they're even, so you could divide by 2. Or you can say, oh, I know 6 times 8 and 6 times 9, so I can divide both by 6. Right? Whatever you saw to begin with, just know that you might have to go further. Right? I say 6 times 8, 8 times 9. So I don't know, what'd somebody do?
I did it by 12.
I did 12.
12, you did it by 2. So let's see. If we do it by 2, I get 24 over 36. They're both still even.
And then divide by 6.
Oh, cool. And then maybe you can see something better. So 6 goes into both. 4 over 6. And then divide by 2, 2/3. So whichever way you did it, should get to 2/3. Now here's something really kind of cool. If I said count by 4s, 4, 8, 12, sorry, amazing. So multiples of 4, things that 4 go into are separated by multiples of 4. See what I'm saying? So how far is 4 and 16? How far apart are they? What's the difference? 4 and 16? 12. And 12 is divisible by 4. That shouldn't be like, ooh, because when I count by 4s, I add 4. All right, now watch. Here's my point. How far apart are 48 and 72? What's their difference? 72 minus 48? 24. Right. Here's a quick way to do it. How far apart are 70 and 50? 20. That's 2 more, so 24. All right, some of you guys, I know calculators exist, but we've got to push our brains a bit. Humans are the ones who created this shit. We've got to always be a little better than the calculators, or else they're going to take over. So what you could have done from the beginning is anything that goes into 24 could be what works. In fact, look at every single number we used. It was something that went into 24. 24 though works. You get that. 48 divided by 24 is 2. 72 divided by 24 is 3. So real quick, a little side note. If I had to do 48 over 54, to reduce that, how far apart are they? So I'm going to try 6. If 6 doesn't work, I'm going to try 2 or 3, because they are things that go into 6. Does 6 go into 48?
Yeah.
Yes.
8.
And 54 is 1 6 more, so it's 9. 8 6s make 48, so 1 more 6 makes 54, 8 9s. Kicking the acid. If you don't like anything I'm saying, you just do it whatever way you already do it. Right? Nothing wrong with doing it in multiple steps. Nothing wrong. As long as you don't stop too early. Just keep going. All right, how are we doing so far? Decent? Okay. Now, let me see if you guys, just to get a little ahead of myself, help me out. What's x times x squared? Anybody know? X cubed. I love it. So I can multiply things that are not like terms. I cannot do x plus x squared. I can't add those because they're not like terms. But what do I have two of here? Nothing. I got this dude and that other dude. They ain't the same. I can't consolidate them. But if I had x squared plus x squared, that would be a couple of x squares. Ooh, right? That's all like terms is consolidate what you can. Right? I wouldn't say I got a chair and a chair and a chair and how many freaking chairs you got, man? You got 11 chairs. So 11C. So I can combine them because they're all the same idea. And maybe, right? Okay, now, to bring fractions into this, when I add and subtract, I must have like terms. Multiplication division is a little more flexible. You don't need perfectly like terms. So look at part D. I keep using green. It's a little hard to see. So here, this is like 11x minus 7y. 11 twelfths minus 7 eighths. They're not like terms. And I'm subtracting. I have to have like terms. Let me show you a little trick. What number goes into both 12 and 8? The biggest number that goes into both 12 and 8? 4. No, the biggest number that goes into them. 4. Now, real quick. These numbers are relatively simple. A lot of you guys saw 24 was the LCD. Are you with me? Some of you guys saw that, right? I'm going to give you a way that works no matter how ugly the numbers get. And we will be doing some ugly numbers later. The biggest number that goes into both is 4. That's 4 times 3. That's 4 times 2. What has he got that he ain't got?
More than 4.
They both got a 4. What has he got that he ain't got? A 3. You guys see that? He's got a 3. He ain't got a 3. He's got a 4. They both got a 4, right? So I'm going to give this dude a 3. Right? What's he got that he ain't got? 2. So I'm going to give this guy a 2. Do you guys understand? So when the numbers get bigger and gross, what do? Break them down to their parts. See who's missing what compared to the other guy. Makes it a lot better than trying to count by 32. 32, 64, oh my God, when do I get this shit? So what do you get here? 22 over 24 minus 21 or 24 equals 124. Is that all right? So just another example. Side note. A little example like this. What you got, Jeff? I don't know, man. Let's do 3 over 16 plus 2. No, let's do 5 over 6. I like it. Sweet. What number goes into both 16 and 6? The biggest number. It would just be 6 doesn't go into 16.
4.
4 doesn't go into 16. 2. 2 times 8. 2 times 3. So what's he need that he's got?
He needs the 8.
He needs an 8. Do you guys see what I'm saying? This will work no matter what. He needs an 8. He needs a 3. So I get 9, 16 times 3 is 48, plus 40, 6 times 8 is 48, holy shit. Kind of makes sense. If you give them each what the other guy's got that they're missing, they're going to end up with the same stuff. I always think about 2 kids with ice cream. He's got 1 more scoop, shit. He's got sprinkles, shit. Now they got the same, go eat. Or if you're still upset, I'll eat it all. No ice cream for anybody, get to bed. All right, yes?
before you do that, you have to find a number that goes in the
Yes.
both of them?
Normally the best is the biggest number that goes into both, because it makes these numbers the smallest that they have to be. But anything that goes into both actually would work. How are we feeling about that? I don't know. Has anybody ever seen that method? Instead of just starting with one and counting until you hit something, the other one works. I always hated that. So this is 49 over 48. What is that as a mixed number? Good. 1 and 1, 48. Just in case they want it like that. I'll tell you what form I want it in. If I don't say, then you can put it whatever form you want to. This is my final form. Okay. So what about, where we leave off? What time is it? I want to go over. E. So remember, when you add, subtract, you have to have like terms. For fractions, that translates into like denominators. E, I'm multiplying. I do not have to have like terms. In fact, what I really want to do then is to reduce stuff, right? Kind of the opposite of LCD, where it builds up. So an E, yeah, I want to reduce what I can. Now, if I look strictly up and down, does anything reduce? No. But all I need is something up and something down. So just to overanalyze this for a minute, what is 15? It's 5 times 3. What is 20? It's 5 times 4. So, of course, the 5's cancel. Because that's 5 divided by 5. So what about 28 and 21? Now look, real quick, how far apart are 28 and 21? 7. So I'm going to try 7s. 7 times what is 28? 4.
3.
7's cancel. Do I cancel these? Oh, hell no. One's not on top and the other one's on the bottom, right? Those are just multiplying. So I get 9 16ths. Is that right? Okay. I can't read some of your faces. All right. Now, dear God, please, what was that I was going to show you? Oh, I did want to show you a little side note about that. Before we do F, how do you divide fractions? Why?
Because it's just opposite. Multiplication is opposite of division.
Let's see. What you got, Jeff? I don't know, man. There you go. Let's do this. All right. Now, guys, promise me this right now. We're about to get into something. Never, ever do it the way I'm about to do it. Then you're like, well, I ain't going to watch you doing some weird shit you don't want me to do. What I'm about to do is something that shows you why what we do works. If you ever thought, like, why the shit do I flip it? Because the dude said so. Guy in the front room said it. It's going to make him happy. Fine, I just want to get to the next thing. I don't blame you for thinking that way, but that's really a bad way to think. You got to take control of your education. You're like, teach me. Tell me why the hell it works. Now, again, I got to keep saying this. I'm about to do something that I would expect nobody to ever do. But this is the first step into why we do what we do. How do I rewrite something divided by that? I do this over. Now, already some of you guys are like, oh, screw that shit. Again, never do this. But this shows you why we do what we do. Okay? I love the look in the faces. Isn't this true? Can't I write this like this? What's 8 divided by 7? 8 over 7, okay? What's this divided by that? This over that. I know it's like fractionception, right? It's fractions inside fractions. All right. This bottom sucks to high hell. What's the best denominator ever to have? What's the best number to have on the bottom?
2.
No, even better. 1. 1 is the absolute best because then you don't need it, right? Isn't 1 the best? How do I make this become 1? Don't have to multiply by, like I have to put a 6 here so those cancel, right? I have to multiply by its reciprocal. Then the bottom becomes 1. That kicks ass. What do I have to do to the top, though? The same thing I just did. So I got to multiply the top by 25 over 6. This becomes 1, this becomes this. Shit. And that's why I flip. That's why you flip the second dude. How are you guys feeling all right?
Yes.
Never accept what somebody says, especially if they're a math teacher, they can't explain it. Say, no, get a different job. Because the purpose of the teacher is supposed to explain why you do that, not just to say, this is what you do. I'm going to explain to you why you do it. This is beautiful. I came up with this a while back. I can't even remember. I was trying to explain it in all kinds of weird-ass ways. I'm like, holy shit, this makes so much sense. I don't remember how it was explained to me. Couldn't even go there. And then here, what can you do? So obviously, you would never do this. You would just immediately go 3/5 times 25/6. This is just me explaining why. Now what can I do? Exactly what we just did. 3 goes into 6 twice. 5 goes into 25. 5 times 5 over 2. Is that cool? Is that cool? So never do this. This is why this works. So what do you do when you have a division of fractions? You multiply by the reciprocal of the second dude. This is why. Okay, maybe? All right. I don't know if anybody's ever been like, why do we do that shit? No? You're like, I'm just going to do it. All right. Let's see, where are we at? Oh, yeah, mixed numbers. It's a funky-ass color. I like it. Low odor. Can't really get high off of those. Give me some extra odor. Markers. Stop. All right. There's several ways to do this. You cannot just go 4 minus 2 and 2 minus 5 because you can't really do 2 minus 5. It's like you have to borrow. Do you guys remember borrowing with mixed numbers? All right, I'm not going to do that first. If I were you, I would change both of these into improper fractions, right? Improper just meaning the top is bigger than the bottom. So it's not truly a fraction. When I say fractional, you think smaller than 1. These are both bigger than 1. That's why I call them improper. How do I change this into a improper fraction?
Take the 7 times the 4, 28, add the 2, 29 over 7.
30.
Oh,
Beautiful. That's fine. We're all good. We're all cool with that. You got the process right. Why?
because the man says.
See? Does anybody know why we do that shit? What? All right. 4 2/7 is one of the worst decisions on how to represent something ever. What the hell is 4? It doesn't mean 4 times 2/7. We know that because that's not just 8/7. This is 4 and. So what we really mean is 4 plus 2/7. And real quick, if you don't like being explained every step, you're going to hate me. Sorry. What 4 over what? Won't this always be over 1? Because that's the whole part. It's always going to be over 1. So what's it always going to need? Whatever's here. So I'm going to multiply this by 7. 7 times 4. There's the first step. Right? And then, of course, what do we do with that? We add it to 2. So one big, I'm not going to say who, but somebody just put a 30 there. Because you go 7 times 4, so 20 plus 2 is 30. But then 4 2/7 becomes 30. Holy shit. So don't forget the over 7. Somebody understand this piece here that he did? That always needs him, and then you're going to add it to this guy. That's why the shortcut works. So I get 30 over 7 minus 19 over 7 is who to who? Oh, I see you. Skip it. So 11/7, which is 1 and 4/7. Cool. Now, if you want to, I'll show you the way to borrow.
Wait,
Yes.
how do you get that number? Because I don't know how to, I know how to get 11 over 7, but I don't know how to.
Oh, sure. All right, I'll show you 2 different ways. The standard way is to just do this. Right? 1, 7, 4, 1 and 4/7. All right, let me show you. Now, I love that look. Here's the better one that you don't ever see. 11 over 7 sucks because 11 is not divisible by 7. Is there a number that's in 11 that's divisible? Yes, 7 is divisible by 7, right? So can't I write 11 as 7 plus 4?
Oh, yeah.
And so this is 7 over 7 plus 4 over 7 is 1 and 4/7. So it's really, notice how you can see there's 4 extra up top. 4 extra up top.
Okay, I get it.
I like it. Hey, Mikey. Okay. Okay. What's the other thing I was going to do? I think that was it for that one. Oh, what time do we go to? I keep forgetting. 12:25. Okay. All right. I don't want to keep you guys over. Don't freak out. Oh, the last ones. These are really, really baby steps towards word problems. The words less than in English are so evil. It's not math's fault. If you learned English second, you know all too well that English is freaky as all shit. It's one of the hardest languages to learn besides Finnish, I would think. My mom's Finnish. They like to put every letter they have in every word they have. But so the phrase less than is evil. If my brother is 2 years less than I am, right, and I'm 45, you want to do 2 minus 45. He's negative 43. He's like, 43 years, he's going to be born. No, I'm from the future. You're going to have a kid in 43 years. Holy shit. So 5 less than 3 is 3 minus 5. It's just the way to translate the English. It's English's fault. And a lot of you guys are like, yeah, a lot of things are English. 5 less than 3. So that's why you end up owing somebody. Yes?
But I did the sign. Why you got it backwards?
I didn't got it backwards. It's English has it backwards. English has it backwards. All right. So if you got 8 apples, hey, listen. If you got 8, apples are overused, but too bad. If you got 8 apples, and I got 5 less than you, I do not have negative 3 frickin' apples, right? Like negative apple, like black hole, right? And 5 less than 8 is 3. It's 8 minus 5. It's the language. It's English's grammatical fault. Do you understand what I'm saying? The phrase less than is evil. If I said, yes. You have a
No, I
question?
just did it in a different way. I did it in this way. I don't know if it's right.
Oh, I see. Okay. We'll talk about that in a minute. So if it takes you 20 minutes to mow the lawn, and I can do it in 5 less than that, 5 minutes less than that, you wouldn't do 5 minus 20, which means I'd be done mowing the lawn 15 minutes before I start mowing the lawn. That'd be nice. I think I'll go mow the lawn. It's done. Shit.
15 minutes ago.
If you take 20 minutes and I take 5 less than that, 5 less than 20, what's 5 less than 20? 15. 20 minus 5. You have to turn it around to make it make sense. Again, people blame math for that. Math's like, it ain't my fault. It's just English grammar puts it the wrong way around. So 5 less than 3. 5 less than 3. There's 3 minus 5. What is 3 minus 5? Negative 2. I like it. If I owe you $5 and I got 3, I still owe you $2. That's another way to look at it. Ain't enough to fill in the debt. I'm still in debt. Signs and money goes together well because we have to live with money and no shit. A lot of us live without money. Understand? The 2 more than. More than implies what operation? Plus. So 2 more than the product of 9 and 8. Product means multiplication. What's 9 times 8?
72.
You get 7. Cute. What about the bonus problem? What are these symbols here? Absolute value. Absolute value is based on what idea? Absolute value always comes out positive. Why? It's based on the idea of distance. So if you're 4 feet away from me, you're not negative 4 feet because I turned around. Negative 4 feet would mean like you're in, Quaid. No. So absolute value always comes out positive because it's the distance. How far apart are 11 and 17? 6. What is 11 minus 17? Absolute value negative 6 makes it 6 because the question is how far apart are these two numbers? They're 6 apart. You're not going to say, you're negative 6 feet away from me, or, you know, where do you live? Negative 20 miles out. You're in the earth. What are you talking about? You're in a black hole. I don't know what this shit. I'm not going to your house. Period. Right? So absolute value always comes up positive, except for one case. What's the one time absolute value does not come out positive? Sort of a trick question.
If the
Absolute value.
is negative? If like the 11.
Oh, I see what you mean. Absolute value is 0. It is 0, and 0 is neither positive or negative. You know, like whatever, Jeff. I told you it's a trick question. But real quick, if the problem was this, what's this?
Negative 1.
Absolute value negative 1 is 1. Then there's a negative sitting outside. So this does not break the rule. The absolute value is positive, and then it says put a negative on it. So the absolute value still came out positive, it just has a negative in front of it. So the answer to this question is negative 1. Do you guys get that? Is that clear? Alright. So I get the feeling that a lot of you guys, well, some of you guys just got the chapter 1 homework right now. So please, dear God, get into that stuff. Come tomorrow with questions. Right? Otherwise, I'm just going to kind of like keep on going and forget all about it. I'm thinking our first quiz is going to be on Monday next week. Just so you have this first week to try to get into the homework. So we'll talk more about that tomorrow.
Are we turning?
Yes, please. Oh, yeah, sorry. I felt like I already collected them. Please turn, pass those up or give those to me.
I have a question. So my friend is asking. My friend is asking.
Oh, I'm sorry. Real quick. This would be if it said 5. 5 less than 3 would be a subtraction. Yeah, don't worry about it.
I have a question.
Yeah.
Yeah.
Yeah.